Today is day 8. We're going to be going over solving quadratics by finding the zeros of the functions by factoring. We're also going to be going over the quadratic formula. We're also going to be going back over standard form, so you should know how to change a quadratic into standard form and use the quadratic formula. And then lastly, we're going to be going over how to get a trend line in your calculator using the quadratic. For problem number 1, it says, what are the zeros of f of x equals 8, parentheses, x plus 4 times 3x minus 2? When it's already factored out like this using tic-tac-toe, or they already have your two factors, you're going to set each factor equal to 0. So I need to set this factor equal to 0 and this factor, 3x minus 2, equal to 0. Once they're set equal to 0, we can go ahead and solve for x. So the opposite of plus 4 is take away 4. So here, the x-intercept is -4 for the left side. On the other one, we have to add 2. So add 2 to both sides. That's 3x equals 2. And then divide by 3. So x is equal to 2/3. So here are my two zeros. Zeros of the function are also known as your x-intercepts. So our x-intercept is -4 and 2/3, which makes our answer F. Now you can always double check it by going to your calculator, going to the graph, and typing in your equation, which says 8, parentheses, the x plus 4, and then your other parentheses, which is 3x minus 2. Now, when I type it in my graph, what am I looking for? Well, I'm looking for the zeros where it hits the x-axis. So to do that, you're going to go to menu 6, 1. So analyze graph and find the 0. So I'm going to find the 0 of the right-hand side, which is 0.6 repeating. 0.6 repeating is 2/3. And then we can follow that same process, menu 6, 1, and find the 0 on the left-hand side to get our solution, which is -4, 0. So again, the x-intercepts were -4 and 2/3. For problem number 2, it says, which of the following functions has zeros of 2 and -5? So here, we're kind of working the other direction. We are given a whole bunch of equations, and we're trying to figure out which one would give me a 0 of 2 and -5. So looking at the first one, I'm going to set the first equation, x plus 2 equal to 0. That's the first factor. So the opposite of plus 2 is take away 2. So x is equal to -2. And then this one would be x equals -5, because the opposite of +5 is take away 5. So the two solutions for A are -2 and -5, which means that that is incorrect because I want to have a solution of +2 and -5. So let's look at B. If I set x plus 2 equal to 0, I would end up with x is at -2. Then I look at the second factor, which is x minus 5. The opposite of -5 is to add 5, so x is equal to 5. So our two solutions would be 5 and -2, which also makes this incorrect. So let's look at C. For C, we're going to set x minus 2 equal to 0, which would give you x is equal to 2. And then x plus 5 equal to 0, which would give you x equals -5. So the two solutions for C would be 2 and -5, which makes that the correct answer because we have a 2 and a -5. Now, could I check that to make sure that I did all of this work correctly? Absolutely. So let's look and make sure that our answer is C. So in our calculator, we would go type in our equation. So in my graph, I'm going to type in the -6 parentheses x minus 2, and then our other parentheses have x plus 5. Here's my graph. What am I looking for? I'm looking for the x-intercepts, the zeros of the function. Where does it hit the x-axis? So again, menu, go to 6, 1, and find the 0. Oops, I didn't shade a proper region. So 6, 1, left-hand side, right-hand side. Shading my region, the right-hand side had a solution of 2, which matches what I have here. Now let's look at the other side. So menu, 6, and 1. We want to find the 0 on the other side, which should be -5, which is correct. So yes, we double checked it to make sure that it is right. Problem number 3, which polynomial equation best represents this graph? So looking at your graph, your x-intercepts are -3 and x equals positive 1. So when I solve the factors, I should end up with a negative 3 and a positive 1. If I set this first factor, x minus 1, equal to 0, the opposite would be plus 1. So the first solution is x equals 1, which is correct. I want to have a solution of 1. But if you look at the other one, x minus 4 equals 0, the opposite of minus 4 is to add 4, so you end up with x equals 4 as my other solution. If you look here, we had a negative 3 and a positive 1, which means that A is incorrect. So again, we want to have a negative 3 and a positive 1. So B would also be incorrect because it has a 1 and the 4. Let's look at C. So for C to be the correct answer, x minus 3, if I set it equal to 0, the opposite of minus 3 is plus 3. So x equals a positive 3. That would also be incorrect. So let's check this last one. X plus 3 equals 0. The opposite would be take away 3. So x is negative 3, which is yes, correct for this side. Now let's check the other factor. X minus 1 equal to 0. The opposite would be plus 1. So x is 1. So yes, this matches. Again, you can always double check it in your calculator by going to your graph and typing in what you have here. What am I looking for? I'm looking for making sure that the graph matches what I have here and that it hits the x-axis at 1 and the x-axis at negative 3. Problem number 4. For problem number 4, it says to use your quadratic formula or completing the square, which we didn't learn how to do that method yet. So we're going to use the quadratic formula to determine the greater solution to this equation. Now, your first step is to make sure that it's set equal to 0, which it is. And then we have to identify what's the A, the B, and the C. Your A is the number in front of x squared, which is 1. The B is the number in front of x, which is 4. And C is the number by itself, which is 2. Now that we have our A, our B, our C, you're going to use this formula, negative B plus or minus the square root of B squared minus 4AC all over 2A. This is your quadratic formula that we learned, and it's also on your formula chart, so you don't have to memorize it, but we're going to go back over how to use that formula. So negative B, which means negative 4 plus or minus the square root. It says B squared, so that's 4 squared minus 4 times the A times the C. So times the 1 times 2. All of that is going to be over 2 times your A, which is 1. All I did was plug in the B where it said B and the A where it said A and C where it said C. Now that we have that, we have a negative 4 in the front plus or minus the square root. We need to figure out what all of that under the square root really is. So what is 4 squared minus 4 times 1 times 2? If I figure out under that square root, it's really just 8. So we're just trying to take the square root of 8 over 2 times 1, which is 2. Now we're going to break our answer into two solutions because this plus and minus. My first answer is negative 4 plus whatever the square root of 8 is. So the square root of 8, if I type that in, it's 2.8. So 2.8 over 2. The other solution is negative 4 minus 2.8 over 2. So notice that I wrote one of them with a minus, one of them with a plus. So in our calculator, we're going to put control divide the negative 4 plus 2.8 over 2. And again, control divide, we're going to put negative 4 minus 2.8 over 2. So one's with a plus, one's with a minus. So these are my two solutions. My solutions are x is equal to negative 0.6 and x is also equal to negative 3.4. It asked for the greater solution. So if you look at these two numbers, the bigger number is negative 0.6. So this is my answer. Now, could I check it to make sure that I did that correctly? Yes, you could go to your calculator, open up a graph, and type in your equation, which says x squared plus 4x and then plus 2. And when I type in my graph, what I'm looking for is I'm looking for where does it hit the x-axis right here. So it's not a pretty number, like it's not a whole number or negative 1, negative 2, negative 3. So again, menu, if you go to 6, 1, it lets you find the 0 of the solution. So the 0 of the solution is negative 0.58, which, yes, rounds to negative 0.6. Okay, and then I can find the solution on the left-hand side by following the same process. Menu 6, 1, and here we go. We have our other solution, which was negative 3.4, so that we have it on the left-hand side. Problem number 5. For the equation 2n squared minus 11 equals 25, what is the solution set? So to solve your equation, we're going to go ahead and use the quadratic formula for this one as well. I'm going to move the 25 over to make sure that it's set equal to 0. So by moving the 25, it becomes minus 25 equals 0. Now these two are just both numbers, so I can actually combine those together, and that's just negative 36 equals 0. Now let's go ahead and figure out what's the A, the B, and the C. Your A value is whatever's in front of your x squared. So in front of x squared is your A, which is 2. The B value is whatever's in front of your x. If you look here, there is no x or n by itself, so that's 0. And the C value is what number is by itself, which is negative 36. Now that I have my A, B, and C, we're going to plug in negative 0, because that's the B, plus or minus the square root of your b squared, so 0 squared minus 4 times 2 times negative 36, all over 2 times the a, which is 2. Now, if you look at this front part, negative 0 is just 0, so that doesn't even need to be written anymore. So my solution is plus or minus the square root of whatever I get under here. So let's go to our calculator, and we have to work out 0 squared minus 4 times 2 times negative 36. When I work that out, I end up with 288 over 2 times 2, which is 4. So our two solutions are whatever the positive square root of 288 is. So square root of 288, we end up with 16.9 over 4. And then the other solution is negative 16.9 over 4. So here I typed in 16.9 over 4 and negative 16.9 over 4 to get my two solutions. So my first solution is going to be 4.225 or 4.2 and a negative 4.2. So here are my two solutions. Now my goal is to figure out which of those matches. Now if you look at C, it just says negative 5, positive 5, which we did not get. So if you look at A, it says a negative square root of 5 and a square root of 5. If you type in the square root of 5, you end up with 2.2. So that's a positive 2.2 and a negative 2.2, which is also incorrect. So let's look at B. We have 9 square roots of 2. If we type that in, we get 12.7, which is not close. Let's try the last one, 3 square roots of 2. So 3 square roots of 2 end up giving, oh, sorry, I forgot the 2 there, 4.2. And then on the other one, we also have a negative, which is negative 4.2. So it matches with D. It's the same thing as the negative 3 square roots of 2 and positive 3 square roots of 2. Again, you can type this in your calculator if you wanted to. You could check it, making sure that the x-intercepts match what we have found here, and you will get the right solution. Problem number 6. The path of a thrown football follows the graph of the quadratic function when the ball is x feet from the quarterback as measured along the ground. The height of a particular throw in feet is estimated and given in the table below. Use technology to find the quadratic function that best fits the table. So for this, we're going to have to go to our fourth little app here, where we have our lists and spreadsheets. You're going to put X and Y at the top for A and B. We're going to type in all of our X values. And then we're going to go to the second column and we're going to type in all of our Y values. Once we've typed them all in, we can then go to Data and Statistics, click your X-axis and Y-axis to move your dots. Now we know that this is a quadratic function, so when we go to menu and to analyze our graph and go to regression, you're going to have to figure out which one says quadratic. So it's a quadratic equation, which means that this is our line, the best fit line. You want to make sure that you don't click linear or exponential, that you click quadratic. So here our equation is y equals negative 0.007x squared plus 1.13 x plus 3. So you're going to look at your answer choices and you're going to figure out which one is closest to what we have written out or what we have on our calculator. The one closest to what we have is C. Okay, we're going to follow that same process for problem number 7. If you look at this one as well, it says law enforcement officials used the length of skid marks on the road to determine the speed that cars were traveling when brakes are quickly applied. So the table below shows various speeds in miles per hour and the length in feet of the skid marks. So it says use your graphing calculator to find the quadratic function. So we need to figure out the equation. And then after we figure out the equation, it says use your equation to determine the most appropriate expected length of a skid mark if driving 65 miles per hour. So 65 miles per hour is somewhere in between here, but remember, because it's a quadratic, it doesn't mean that it's going to be halfway between here. So what we're going to do is we're going to go to our calculator, lists and spreadsheets. Same process, we're going to put X and Y and type in our values. Once we've typed them in, you're going to go to Data and Statistics, clicking X and Y. And again, you need to go to Menu, Analyze Graph, Regression, Quadratic, because it's a quadratic equation. Now it gives you this nice long equation. You do not have to write the whole thing, but the more numbers that you have written, the closer you are to your answer when you look at your answer choices. So here we have 0.0514 x squared minus, the plus minus becomes just a minus, 0.4028 x, and then plus 4.6857. So again, remember, the more numbers that you write, the closer you are whenever you get your graph. So here we're just going to go to our graph and we're going to type in the equation that we ended up with. So 0.0514 x squared minus 0.4028 x plus 4.6857. Here's my graph. Pop up your table, Control T. Our goal is to get all the way to a speed of 65 miles per hour. I can scroll down till I get to 65, or a faster way to do it would be go to Menu, Table, Edit Table Settings, and then go to Table Start and tell your calculator to start at 60 or 65, wherever you want to start. So at 65 miles per hour, I would expect this car to be to have a skid mark length of 195 feet or 195.6. So that would round to 196. So the answer for this one is going to be G.